that is not rigid or mechanical, but fluid, responsive, and deeply interconnected with our own presence and awareness. The interplay between scientific observation and philosophical reflection makes the study of time dilation deeply enriching. The rigorous empirical evidence from physics provides a firm foundation upon which imaginative exploration can flourish. By examining thought experiments, the twin paradox, and gravitational time effects, we can see how deeply counterintuitive yet real these phenomena are. At the same time, philosophical inquiry allows us to contemplate what it truly means to experience time individually and collectively. The recognition that each consciousness may experience time differently invites reflection on free will, destiny, and the role of perception in shaping our reality. This merging of science and philosophy creates a space where wonder, curiosity, and intellectual engagement are naturally intertwined, encouraging us to question assumptions and explore the limits of human understanding. From a practical standpoint, appreciating time dilation can enrich our everyday life. In recognizing the subjective nature of time, we may develop greater patience, awareness, and presence. We might savor moments of connection and achievement with heightened sensitivity and respect for the personal timelines of others. The insight that time is flexible encourages us to prioritize experiences that are meaningful and fulfilling rather than merely chasing uniform clock time. It also enhances our appreciation for the precision and complexity of scientific instruments and technologies that account for time dilation and enable navigation, communication, and exploration on Earth and beyond. In essence, the study of time dilation offers both intellectual stimulation and practical guidance for living a richer, more conscious life. Time dilation also invites us to reconsider the narrative of human history and future possibilities. If the passage of time is not absolute, then our collective story is not written in a single linear timeline, but potentially in multiple overlapping and interacting temporal streams. This perspective opens doors to imaginative possibilities for understanding history, events, and outcomes in ways that are not strictly deterministic. The mind-bending nature of time dilation pushes the boundaries of imagination, encouraging speculation about parallel experiences, alternate realities, and the profound influence of perspective on what we perceive as objective truth. It compels us to think about the universe as a dynamic and responsive system in which each conscious participant experiences a personalized journey through moments and events. Consider the astonishing implications of time dilation on our understanding of human experience and the very structure of the universe. If time is not uniform across different frames of reference, then each conscious being might be inhabiting a reality slightly different from those around them. This leads us to a profound realization that our perception of simultaneity could be inherently flawed. What we take to be a shared moment might in fact be a patchwork of slightly misaligned experiences, stitched together by our limited senses. The consequences of this idea are both fascinating and disorienting, because they challenge our most basic assumptions about what it means to live in the present. The universe as we perceive it might not be a singular cohesive entity, but a mosaic of overlapping individual timelines, each shaped by motion, gravity, and the unique consciousness of the observer. This perspective urges us to reconsider not just physics but philosophy, psychology, and even the nature of personal relationships, because our interactions with others may involve a subtle interplay of differently dilated temporal experiences. The mind-bending nature of the twin paradox provides a concrete illustration of this phenomenon. If one twin embarks on a journey through space at speeds approaching the speed of light while the other remains on Earth, the traveling twin will age more slowly, as measured by the earthbound twin. This outcome is not a matter of opinion or perception, but a measurable physical reality confirmed by countless experiments with high-velocity particles and precise atomic clocks. The implications extend far beyond thought experiments to real-life scenarios involving space travel and high-speed transportation. As humanity ventures further into space, understanding time dilation will become crucial for navigation planning and even interpersonal relationships between astronauts and people remaining on Earth. The twin paradox forces us to confront the uncomfortable notion that aging and the passage of time are not absolute, and that our personal experiences of moments could diverge dramatically from those of others in ways that are entirely real and scientifically predictable. Moving from velocity-induced time dilation to gravitational time dilation reveals an equally fascinating aspect of the universe. When mass bends the fabric of space-time, it alters the passage of time itself. Objects deep within a gravitational well experience slower time relative to objects farther away from the source of gravity. This effect is not merely theoretical, but has practical implications for the functioning of technologies such as GPS satellites, which must account for these minute differences in order to provide accurate positioning. The idea that gravity can influence how fast we experience time suggests that our perception of reality is intimately linked to our environment and location in the cosmos. In extreme cases near black holes, time slows to an almost incomprehensible degree, meaning that seconds for an observer near the event horizon could equate to years for someone far away. These extreme examples stretch our imagination and force us to think beyond the constraints of everyday experience. They demonstrate that the universe operates according to principles that are profoundly counterintuitive yet verifiably true, and that our personal experience of time is just a small window into a vast and intricate temporal landscape. Even within the comparatively gentle gravitational environment of Earth, subtle variations in elevation or speed can produce measurable differences in the passage of time. Two people standing at slightly different altitudes or moving at slightly different speeds may experience the passage of seconds differently according to Einstein's equations. Although these differences are minuscule and imperceptible without precision instruments, they nonetheless exist and reveal the inherent relativity of temporal experience. This notion challenges our everyday assumption that time is the same for everyone. It suggests that reality is deeply individualized in ways we are only beginning to comprehend. It also inspires contemplation about the ethical and philosophical consequences of these differences in temporal experience. For instance, could there be scenarios in which recognizing subtle personal variations in time becomes significant for medicine, space travel, or human interactions? The study of time dilation encourages us to explore such questions with curiosity and imagination, expanding our understanding of what it means to live in a universe where time is not a constant but a dynamic and context-dependent phenomenon. The psychological perception of time adds yet another layer of richness to our exploration. Time is not just a physical dimension but a lived experience that can expand and contract, depending on attention, emotion, and engagement. The minutes spent in anticipation of exciting news can feel like hours, while an afternoon immersed in a captivating activity can pass in the blink of an eye. This subjective elasticity mirrors the physical time dilation predicted by relativity and suggests that consciousness plays a significant role in shaping our experience of moments. The combination of objective and subjective time